we have almost covered every topic from our computer-oriented numerical method subject. So all the modules has already been covered and they are arranged systematically in your Google Classroom. There are two topics that I have not taught you yet. One is your Romberg method from the numerical differentiation integration, and another is predictor corrector method from the ordinary differential equation. So let's start with this, the predictor corrector method, which falls under your ordinary differential equation. Over here what happens is that in this Milne's predictor corrector method there are two formulas. The first formula is your predictor formula, with the help of which you are going to predict a value, and then you have the corrector formula with the help of which you are going to correct your predicted value. So this is how it works out. So in such kind of problem you will be given the dy by dx. Now dy by dx is also known as y dash, isn't it? So you know this. So this will be given to you. It is your function, and along with that you will also be given the initial values. That is at x0 what is your y0. These two will be given to you. Once you know these two, then you are asked to find out what is the value of your function, that is y, at a particular point which is xn. Now in Milne's predictor corrector method, there is one thing which you need to keep in mind. The initial point and the value at which you need to find out, the difference between them has to be in steps of 4 and more. So minimum number of steps should be 4. So before, since x0 is this which is given to you, x0 is given to you, so your numerical solution should have at least x1, x2, x3 and x4. It can have more than x4, it can have x5, x6, x7, many number of things, but it has to have at least 4 of them. So what is your x1? x1 is your x0 plus h. What is your x2? x2 is your x0 plus 2h. What is your x3? x3 is x0 plus 3h. What is x4? x0 plus 4h. You already know how to calculate this, isn't it? So once you know this, suppose I have x0 as the initial point and I have divided into 4 parts. In that case, what will you do is that for the first three, x1, x2 and x3, you are going to calculate y1, y2 and y3 with the help of any of the method that we have discussed till now. The Euler method, the Euler modified method, the Runge-Kutta method, or the Taylor series method. These methods. This Taylor series, Euler method, modified Euler method, Runge-Kutta method. So use any of them in order to calculate your y1, y2, y3 and y4. So these y's will be calculated. Now once you have this y, the last value which you need to calculate, for that you need to use your Milne's predictor and corrector formula. Now from where you will get your x1, x2, x3, all you have to do is that add h to your x0, and then you can, if it is x3, then it will be x0 plus thrice of h. Now once you know that, by using either Euler, modified Euler, Runge-Kutta or Taylor series, you calculate your y. So once you know your x and y, just put those x and y in your function and calculate your y1 dash, y2 dash and y3 dash. Just calculate them, y21 dash, y2 dash and y3 dash, using this x1 and y1, x2 and y2 and x3 and y3, which you have just calculated by using any of these methods. So once you have this, use this, put the values on your Milne's predictor formula and calculate your y4. Once you know your y4, you correct this y4 by using Milne's corrector formula from here. Now if you have more than x4 parts, in that case what you do is that you for the first three you will do as it is. For first three, x1, x2, x3, y1, y2, y3, you can use this and you find out. Then y4 you find out using the predictor method. Once you know the y4, then you modify the y4 using the corrector method. Then you find y dash at y4, and then you use this in your y5 and y5 dash corrector, and so on and so forth. So let's see with an example. Using Milne's corrector, find the solution for dy by dx is equals to x minus y square in the range of 0 to 1, and the boundary condition is at x0 you have y0. So what you are given is that this dy by dx, which is also your y dash, is known by y dash, which is basically your f of xy, is equals to x minus y square. So you know this. Also your boundary condition is given to you, which is x naught and y naught. So y of 0 is here 0. So this is also given to you. You are asked to find out at y1. So what is, as per the mean list formula, what you have to do? You have to divide your 0 and 1. From 0 to 1 you need to reach, na? So you have to divide them in at least 4 parts. So for your sake I am dividing it into 5 parts, and let's see how it works out. Since I have need to divide into 5 parts, so my h will be 0.1. Hence x naught was 0. What is x1? It is x naught plus h, so it is 0.2. Then what is x2? This plus 0.2, which is x4, 0.4, 0.6, 0.7, and ultimately in the fifth part I am getting my 1, which I need to calculate. So as I have told you, using either the Euler method, modified Euler method, you just calculate, or any of the Rangaputra method, just calculate your this x, so you know, x1, x2, x3 you know, this x1, x2, x3 you know. So use this x1, x2, x3 and calculate your y1, y2, y3 using the Euler method, modified Euler method, Rangaputra method, or any method. I have not calculated it for over here. You do it yourself. So these are the things you are going to get. Also remember, while doing such kind of numerical calculations, your values may differ slightly because it depends upon what accuracy you are considering. So it will be nearby to these values only. Now I have my y1, y2, y3 by using any of the 4 methods. Now what I will do is that I will be calculating y1 dash. So what is your y1 dash? What is y dash basically? Y dash is this function only. So just put, then what will be your y1 dash? What will be your y1 dash? It will be just x1 plus y1 square, and you already know what is your x1, and by Euler method you already know what is your y1. Just put them over here and calculate your y1 dash. Similarly calculate your y2 dash, then your y3 dash. Now you have everything. Then you can easily calculate using CONM Predictor formula. You can calculate your y4. Just use the formula, put the values, and you can calculate your y4. Once you know your y4, you can then know what is your y4 dash. Just put this x4 and y4 and calculate y4 dash. Then use the corrector formula to calculate your y4. Just correct your y4 using the corrector formula. Just put the values and you can calculate. So you have your y4. Once you have your y4, just calculate your y4 dash using the formula. So up to now you have calculated y4, but y4 is not your solution. You need to calculate at x is equals to 5, isn't it? So you need to calculate at x is equals to 5, hence you need to calculate y5. So go to y5 now. Go to y5, use the predictor method to calculate your y5. Once you know your y5, correct it using the corrector formula, and then you can easily calculate. So this is the basic CONM corrector formula, predictor corrector formula. Just go through the numerical. If you face any problem, you can WhatsApp me or post in the Google Classroom. Thank you.